module from the chapter Some Application of Trigonometry. Let's do a sum based on angle of elevation, and this is going to be very interesting, beautiful sum. Let's observe the sum. It says that the angles of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of a tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meter. Now, when you read the sum, it seems to be very confusing. Now, at least we know that it means there is a tower which is existing here. We're talking about a tower. And they're talking about angles of elevation. That means there are more than one angle, right, which are formed. Now, what have they said? The angles of elevation of the top of a tower. That means these angles of elevation are formed when an observer is observing the top of the tower, right? From 2 points. So, one angle is made from one point and the other angle is made from the other point when that observer is observing the top of the tower. But where are those points located? Let's see. From 2 points at a distance of 4 meter and 9 meter from the base of the tower. That means there are 2 points you need to consider, right? One would be at a distance of 4 meter from the tower and the other one would be at a distance of 9 meter from the base of the tower, right? And the next thing said is, and in the same straight line. That means all those 3 points, the base of the tower, the point which is a distance of 4 meter and the point which is at a distance of 9 meter, all those 3 points are collinear. That's the most important thing. So let's say we consider 1 point now, right, from the base of the tower. We consider 1 point which is at a distance of 4 meter, right? So we say there's an observer observing from there, right? And there's another point at a distance of 9 meter from the base of the tower, right? Now, remember, see the base of the tower, that 4 meter and the 9 meter, this all three are collinear, right? From here, the angle of elevation is made, but there is no height of the observer. That means the height of the observer is to be neglected. The angles of elevation are made. That means from here, from the first point, there is a line of sight to the top of the tower. So, there is the first angle of elevation. From the next point, there is another line of sight. So, there is another angle made. So, 2 angles of elevation which are made, right? Angles of elevation not given to us. Right? But what have they said? Are complementary. That means these angles of elevations which are made, they are complementary. When we say complementary, that means the sum of those 2 angles of elevation will be 90 degree. That means this, let's say, if you consider the one angle to be theta, the other angle has to be 90 minus theta, because the sum of these 2 angles is 90, right? So one angle is theta, so the other one is 90 minus theta. Is that clear? And what are we supposed to find? We are supposed to prove rather that the height of the tower is 6 meter. Now this is what we need to prove in the sum. Seems to be different, but seems to be very interesting. Now you just draw the figure and the figure is going to look like this when you draw it in the book, right? Easy till now, it's very simple, don't worry, very, very easy. Let's move ahead. Now I said, now when you look at this particular sum, you realize there are 2 right angle triangles. And I've always said, whenever you have 2 right angle triangles, the most important thing which you need to focus is going to be the common side. Here the common side is AB. Let's list down the description of the figure. So here we say that AB, that is the height of the tower, and we take it as H. The first job is hold on to H. That is very important to us, right? Now we need to prove that height is 6. We need to prove H is equal to 6 meter. That's the important thing here. Okay, what is AC? Now AC is nothing but that is the distance of that first point C from the base of the tower, which is 4 meter. Then we can say that DA is nothing but that is the distance of D from the base of the tower, which is equal to 9 meter. And angle ACB we know is given as theta. We took it as theta. So ultimately from that we came to know that angle ADB is equal to 90 minus theta. Now this is the information which we gathered when we were solving the sum. Let's move ahead. Now we consider the first right angle triangle here, that is right angle triangle BAC. In this right angle triangle, observe the acute angle as we have done in so many sums till now. Simple, right? Observe that angle. For that angle, what is BA? We have BA as the opposite side and we have AC as the adjacent side. So we are talking about opposite side and adjacent side. So which ratio comes to our mind? Yes, it is nothing but tan. So using tan for that angle theta. So we write tan theta is equal to AB upon AC. Now we don't know the value of tan theta. Keep it as it is. So tan theta remains as it is. That is value of AB. We know we have taken it as H, and the value of AC is nothing but 4, right? So we got the value of tan theta here as H upon 4. Let's move into the next right angle triangle. What is that? It is triangle BAD. In this right angle triangle, observe that angle D. For that angle D, what is the opposite side? The opposite side is AB, and the adjacent side is AD. So when we look about opposite side and adjacent side, which ratio comes to your mind? Yes, the ratio which comes to your mind is tan. So we use tan again, but tan for which angle? Tan for 90 minus theta. So we write tan of 90 minus theta is equal to AB upon AD. Now students, when you solve it further, you know what is tan theta? Right, tan 90 minus theta is equal to AB. What's the value of AB? We know the value of AB is nothing but we have taken it as H, and the value of AD, what is AD? AD is nothing but it is 9. So we substitute that value there. Now students, how do you solve it further? Now you say tan of 90 minus theta. Now this is nothing but it is the trigonometric ratios of complementary angles, and from tan 90 minus theta we realize it is nothing but equal to cot theta. So we write that cot theta is equal to H upon 9. But in equation number 1 we have the value of tan theta. So let's convert this cot into tan. Can we do that? Yes, we can, because we know that cot theta is nothing but it is 1 upon tan theta. So we can write here 1 upon tan theta is equal to H upon 9. Now this is what we obtained. Now let's solve it further. Now from this equation we can get the value of tan theta. So take tan theta onto the right hand side. So hence 9 comes here in the numerator and H comes in the denominator. Hence in the next step we'll get tan theta is equal to 9 upon H. And when you look in statement number 1 which we have there, tan theta is H upon 4. Substitute that value here on the right hand side. So you'll get 9 upon H is equal to H upon 4. And now cross multiply. So H into H becomes H square is equal to 9 into 4, which is 36. So we get H square is 36. That means we know H is equal to 6. And we got the value of H as 6. That means we got the height of the tower, which we took it as H as 6. So we write now, therefore we got the height of the tower is 6 meter. Wasn't that easy? A simple one. Easy, right?